Hello, everyone. Welcome to today's Data Science 101. Thanks for joining us. My name is Jose Arpin, and I am part of the Growth and Development team within the YP Calgary section. First, I'd like to start off by thanking our sponsors for today's webinar, Chevron, Geologic Systems, Hexion, and the Young Professionals venue sponsor, Ovintiv. Just some quick webinar housekeeping before we begin. The session will be recorded and can be later found on calgary.spe.org. We do have a Q&A box for questions, so please feel free to ask questions at any time. Just please be sure to use the Q&A box as opposed to the chat window, and we'll make sure that we get to all the questions throughout the presentation and as well as at the end. All of our attendees' microphone and video are currently muted and off, and will be off for the duration of the webinar. So with that, let me introduce today's speaker. So Roman is an assistant professor and associate head of undergraduate studies in the Department of Chemical and Petroleum Engineering at the University of Calgary. He holds a bachelor's in mathematics and a bachelor's and master's in computer science from the University of Pennsylvania, as well as a master's and PhD in petroleum engineering from the University of Texas at Austin. Roman is the lead investigator at the Drilling Research Laboratory and currently serves as the Director of Technical Programs for the SPE Calgary section. When he's not on campus or at the lab, you can usually find him on the slopes in search of the best turns. Without further ado, I'll turn it over to Roman.
Awesome. Thank you for that kind introduction. And thank you everyone for joining today for a brief introduction to Data Science 101 over your lunch break. As we get going, one quick piece of logistics. All the course material can be found online. So these links have been shared in the chat. If we can go ahead and just paste them back in the chat one more time for any latecomers. If you go on this page, you'll find this slide deck along with a data set and a Python notebook that you can follow along with. So for most of this webinar, I will be using Jupyter Notebooks and actually going through how you would use Python to interact with this data set and extract information from it. If you want to follow along at the same time, go ahead and have Python open on the side. Otherwise, this Python notebook along with the solution will be shared, and you can then go play with it at your leisure later on. So the agenda for today is we're going to talk a little bit about what data science is, briefly touch on some of the tools that are out there, and then we'll move over into live coding in Python. Over the course of the webinar, I will be keeping an eye on both the chat and then the Q&A. Primarily at the chat. So if you have questions as we're going, please type them into the chat and I will try to address them. Otherwise, I will be addressing Q&A at the end of the webinar. So again, I like having these webinars be somewhat interactive. I know all of us have been sitting at home for a very long time and are starting to miss out on some of that interactivity. That's very true for me because I've been teaching from home for the past almost year. So any interaction is always positive interaction. So as we get started, just quickly, who am I? I work on drilling automation, applications of AI machine learning into energy and also in geothermal energy systems. So looking at how do we make geothermal energy economic and what technology needs to exist for it. I do work with quite a few companies in Calgary and in North America, and with a lot of funding also coming from the Canadian government. So I'd like to acknowledge those companies and thank them for their support. But enough of me. What about you? What is going to be the primary goal of, or what do I want you to walk away from this lunch webinar with, other than having had your lunch at your computer? So the number one thing is understand what data science is, how it relates to machine learning and AI, and how it can help you in your everyday role at your company and also outside of, let's say, your day-to-day day job. I want to go through and help you become familiar with some of the popular tools, primarily Python, but I'll also mention some of the other ones that are available. And then we'll go into a deep dive and load and visualize some data in Python. So again, Python is one of the simpler programming languages out there. It's scripted and it's very interactive. And what I want to try and do is try to lower that barrier of entry into Python for working with data. And I want to show you why Python is superior to, let's say, Excel for looking at that specific data. And at the very end, if we still have a little bit of time, I would like to do a basic regression of that data set and quickly show you what that regression can do with it and whether or not a certain metric, so let's just say R-squared value for a regression, is actually a reasonable thing to use when looking at assessing, let's say, the prediction value of a regression. So that's the goal for today, and I'll hopefully end up by that fourth bullet point by around 12:45, 12:50. So to begin, what is it? Everybody hears these various buzzwords thrown around: machine learning, artificial intelligence, deep learning, data science, the digital energy, the data revolution, etc. What are these actual, what do these words actually mean? So from these three that are just on the screen right now, all three of these actually refer to the same overall concept. Machine learning is simply let's say a field of study where you're looking at enabling a machine to find patterns. So a machine being a computer, that computer is going to find patterns in your data, and then from those patterns, try to create, let's say, predictions. Artificial intelligence, machine learning is a part of artificial intelligence, where artificial intelligence takes that machine learning and then applies it to a specific problem in order to do optimization or to do control. So you can think of artificial intelligence as taking that subset of machine learning and then applying it to a problem and then taking an actual action based on it. Deep learning is a subset of machine learning. So deep learning is actually a method used within machine learning in order to achieve that prediction. So deep learning in general is what we typically think of, or what we hear when we hear deep learning. It's simply using neural networks that have more than one hidden layer. So a neural network is effectively, it follows how our neurons are set up in our brain. But at its simplest, a neural network is just a nonlinear summation of linear regressions. So you have this neural network, which combines a bunch of parameters, has these hidden layers. If you have more than one hidden layer, you are now effectively doing deep learning. The reason why deep learning is so powerful is by adding on those additional layers within the neural network and adding on additional nonlinear activation functions, it allows you to fit patterns better if you have extremely large data sets. One other definition that's thrown around a lot is this idea of big data. What is big data? To us as individuals, big data might simply mean a 50 megabyte data file that we're trying to work with. That's not big. To a company, big data might mean the gigabytes or hundreds of gigabytes of well data that they might have. That is starting to approach getting big, but still, that is a fairly small data set. Big data in the outside world, at, let's say, Google and Facebook, you're looking at hundreds of terabytes to petabytes of data, and that data is then applied to these deep learning algorithms. And in it, you have a humongous training set, and from that, many layers within these neural networks, and then from that, you can actually get fairly reasonable predictions. The problem with trying to apply some of those methods to our data sets is the fact that they're so small. We have very little data when we look at the comparison with, let's say, social media and things like that. All right, there is one question in the chat asking about Python versus R. So Python is becoming quite popular because it is a programming language that allows you to not only interact with data, but then also display data and create, let's say, interactivity that is not just programming. R allows you to interact with data and find results. Python allows you to build applications or even web applications that are now more, let's say, point and click rather than just being that data processing. So from that, Python becomes that more powerful tool. R is just really still that statistical language, and that is it. All right, So within data science covers the entire spectrum from collecting data to using that data. So at the very bottom level, you need to be able to go out and collect your actual data. So you start with that collection. This is where you have your instrumentation, your logging, you have your user-generated, let's say, inputs into the system, etc. This right here is that lowest level raw data collection. Understanding the data collection is critical in order to have useful data. One of my favorite stories that I've ever heard was a drilling rig somewhere in the Southwest US. Every day they would see a spike in weight on bit. So they would be drilling along, and all of a sudden every day there was the driller would, or the office would see an increase in weight on bit without an increase in performance, and they would always call the driller, "What are you doing? Lay off the weight on bit," because you don't want too much weight on bit, because you either get whirl or you can destroy your tools. This was happening every day, and it was only happening for half an hour. So they went and did a deeper dive. They realized that the weight on bit sensor, which is a strain gauge, was in the sun for that half hour of the day. The rest of the day it was in the shade, but for that half hour it was in the sun. If you have a mechanical strain gauge, it is affected by heat or by the temperature of the sensor. So their increase in weight on bit was nothing physically wrong with the actual drilling process. It was simply sun hitting a sensor. So when you're collecting that data, it's critical to understand how that data is actually collected and what external factors can change that data. Once that data is collected, it needs to be moved and stored somewhere. So this is that whole concept of, let's say, edge computing and the cloud. So the cloud is simply a term that it now refers to storing data on a server farm that is somewhere outside of your control. So a server farm at a company is an internal cloud, or as we used to think of it, a local mainframe. A full cloud is something that is out somewhere. So it's either owned by, let's say, your Microsofts, Amazons, your Googles, etc. And you are putting your data into that location in order for that data to be accessed freely by, let's say, users that have that access. So a cloud is simply a glorified version of that old mainframe that used to store all of your data centrally. The key thing with this is when you're storing this data is how easy is that data to access once you've stored it. A CSV file on one of your laptops is great for you. It's really hard to access for the next person who wants to use it. So having that, let's say, that clean data repository is something that's critical in order to optimize this overall workflow. Once you've stored that data, you can start, let's say, exploring and cleaning it. Cleaning simply means removing error values, looking for, let's say, errors in that data. So is that sun hitting that sensor? So that's a critical point. After a certain point, once you cleaned up your data, then you can start looking at aggregating and labeling it. Labeling is when a human goes in and identifies what's happening in the data. And that is critical for the next step, which is then looking at your machine learning, because the computer can either try to find its own patterns or it can try to model a pattern that already exists. So that's a pattern that you've already identified and labeled. Labeling simply means identifying that target. So for drilling, for example, labels can simply be a driller going in saying, this is good drilling, this is drilling with vibration, this is poor drilling, etc. Or you can also label it and say, at this event, the bit broke, or at this event, we had a well kick, or at this time. If you have a pipeline, same thing. At this time, we had a leak, and this is what the data looks during that leak. Now, once you've gone through and started to, let's say, apply some of those initial machine learning algorithms, then you get to the AI and the deep learning. The deep learning, in this specific case, I wouldn't keep at the top of this pyramid. I would actually move it down here. But AI is that top step where you are actually going in and taking those models that you've developed and now starting to apply them in something that's operational. Whether or not that is for, let's say, failure detection or anomaly detection, or for actual optimization. So for the machine learning, there's three different types of methods that you will frequently hear about. There's supervised machine learning, unsupervised machine learning, and then reinforcement learning. Supervised is the computer, or is the algorithm is trying to match labels that you have created. So either it's trying to match, let's say, some time data. So let's just say you have a bunch of wells and you're looking at well production. If you're trying to, let's say, predict the production from new wells based on old wells, that right there is supervised learning, because you have that data that you're trying to, let's say, match. Unsupervised learning is when you don't give it, let's say, that target. So typically what happens for unsupervised learning, you will either go through and start looking at clustering. So you're looking at, let's say, relationships between variables, or you're trying to reduce the dimensionality of that data. So let's just say you have 200 parameters, but 200 columns in your spreadsheet. Unsupervised learning can help you reduce those 200 columns down to, let's say, 5 or 6 of the key columns. Or those columns can also be made up of some of those other parameters. So if you ever looked at, let's say, principal component analysis is effectively unsupervised learning. And then finally, reinforcement learning, that is more of a game-based approach to teaching a machine to do something. A good example on this is, let's say you're trying to teach a car to drive. You allow the car to effectively take control of the wheel, and then you give it a reward for when it does something good. So doing something good, staying on the road. So every time the car crashes, it gets a negative reward. Every time it stays on the road, it gets a positive reward. So this is, again, using a little bit of human behavior in order to try and put that into the machine learning itself. This works quite well. However, for applications that we're looking at, generally you do that training on simulation before you try to apply it to that real system, because you don't want that machine learning algorithm to fail while it's controlling, let's say, a real system. So that training is something that's critical for this. And this is why self-driving cars have taken so long. It's because it's been 10 to 20 years of that actual application going forward. So there's a question about what's a positive, negative reward for that algorithm. So generally for all these algorithms, they have something called a cost function or a reward function. So based on a series of, let's say, inputs, so this can simply be a series of actions, there is a reward that's given to them. A negative reward can simply be a negative number. A positive reward can be a positive number. And then from this, you choose the algorithm that gives you the highest reward, so that highest positive. So it's the same exact way that, say, you're trying to teach your dog to sit. Every time it does something good, you give it a treat. And then over time, it knows if it sits down, it gets a positive reward, so that treat or a positive number. So over time, we'll then start associating sit with actually sitting down. So it's that same concept, except instead of a treat, you're just giving it a number. So positive for a positive reward, negative for a negative reward. This is a very busy slide, which is with a cheat sheet of all the various algorithms. I will leave this for you for once you start, let's say, if you want to do a deeper dive into machine learning itself. But my goal now is to go into Python and, let's say, look through some of the basics of using Python to play with data. So the objectives for this is going to be load a CSV file. That CSV file is available on that website that was shared. In it, there's 6 hours of drilling data. This drilling data, you can open up very easily with Excel. It's only about 20,000 rows. Or if you're playing with, if you're using Office 365, Power BI is another tool that's often used to play with these. Excel will allow you to just open that file and then apply transformations to it. However, it doesn't save that workflow that you're actually applying to it. Power BI adds that ability to save that workflow, so you can apply that workflow now to different files. Again, it's more of a visual tool where you're clicking, selecting equations, etc. I'm going to use Python simply because it's the most programmatic way of doing it, and it's the easiest way to apply that same workflow you develop to new files in order to start building up either a database or simply applying a workflow to additional data. So within this, we're going to plot some data, then we're going to select a subset of the data, and then we're going to do a very simple multivariate regression to predict drilling rate. So with this will give you those steps in order to go from here's your data file to now what's that simple machine learning algorithm that's on top of it. All right, and as I do it, I'm going to quickly stop share and then share Chrome. And I want this guy. All right, so everybody should be able to see my Chrome window now. Give me 1 second to pull up my cheat sheet at the same time and get the chat open again. All right, so what I have up right now is the website that was linked to. On there, you will see at the bottom the PDF of the lecture notes themselves. So that's a good reference for you for later on. And then there's 3 links at the bottom for the Python notebooks. So there's an IPYNB file. That's the interactive Python notebook. There's a PDF of that Python notebook that you can look at if you don't have a Python interpreter installed. And then the last one is the data file that we will be playing with. If you're doing this along with me at the same time, a key thing is to have the data and the Python notebook in the same directory when you open them up in Jupyter. So in my Jupyter directory, I have that data file. So it's edrdata.csv. And I also have that Data Science 101 workbook, the IPYNB. In here, you'll also notice that I have a couple solution files. I am a faculty member, so I always have my cheat sheet ready. And then I also have the PDFs of everything I've been presenting. So that's what these other files are in here. Once you open up your Python notebook, you will see something that looks a lot like this. So in Python, one of the big things that Python provides is this ability to create these Python notebooks. Python notebooks allow you to mix markup, so effectively text explaining what you're doing, along with actual code, and allows you to run that code in that same file. A Python file, so that a .py file, only allows you to have code in it along with comments. And those comments can explain what you're doing, but they're just simple text. So Python files are great for once, let's say you're running something in the background or processing a large number of files. Python notebooks are a great way to organize your thoughts and pretty much explain what you're doing in a very visual way. So in this Python notebook, my first little blurb is just me explaining what we're trying to do today. So objectives, open some stuff up. If you double click on this box, it'll give you the actual code formatting that's in the back end. And you can see that it's quite easy to actually put together very nicely formatted text in these Python notebooks as you're running through them. To run something, just do Shift Enter or Control Enter, depends on your system. If you're on a Mac, it might be Command Enter. So what we're gonna do is we're gonna start off loading and processing our CSV file, and then we'll get to plotting of it, and then we'll get to machine learning. So for importing data, there's several different ways you can do it. You can do it using the CSV library. You can use it using this library called NumPy, so numeric Python. And then finally, you can use this library called pandas. What we'll do is I'll quickly go through how you would do it for each one. And then I'll show you why pandas is the nicest way of doing it, but it's also the most complicated, where if you don't know necessarily, let's say, the format of your file, pandas might fail. So it's always good to be familiar with how to do it all 3 ways, because so then that way you can go through and figure out why a certain method isn't actually using. So what you should be able to do with this file as well is if you run all the code right now, so there's a very little code in this notebook, it should be able to run. If you're getting error messages right now, that simply means you're missing one of the libraries. So we just need to go and figure out how do you install, that specific library. There is one question right now in the chat asking about how do you install Python. Python is open source and free. All you have to do is just go find Python and install it. The easiest way to install Python is using a package called Anaconda. Anaconda will install everything you need with Python to do data processing. So I'll just go ahead and quickly show that to you. So if you just simply search for Anaconda Python, the first thing you will find is the individual edition for Anaconda. And in it, you'll be able to go ahead and download it. So for pricing, the individual license is free, and then you can go ahead and download and run with it. It has everything you need for that to process data with it. All right. So you have a CSV file, you want to open it. So in Python, the way you open a file, there's several different methods, but the simplest way is simply saying with open what the file name is, edrdata.csv, and we want to read the file, and we want to access it as file. So in Python, we've imported the CSV library, and now we want to open the CSV file as read-only, and we want to be able to access this open file as just this name file. So this right here is a variable. You can call it whatever you want. So now what we're going to do is we're going to go ahead and create pretty much a reader for this file. Reader is csv.reader of file. So we've now created a file reader using the CSV library, and we've sent this CSV file into it as that function. Now let's go ahead and read the CSV file. And I also only want to read the first 10 lines. So let's add a comment. Let's read the first 10 lines. I don't want to read all the lines because otherwise I'll be printing out 17,000 lines. And that works pretty quickly, but it's not particularly useful when it's printed on a screen. So for that, we need to create a variable called counter, and then for row in reader. So for each row in the CSV reader, let's just go ahead and say print row, increment our counter. And then finally, if our counter is greater than 10, we want to go ahead and break. So what's happening here? We created a variable that starts at 0. Now we're going to, for each row in the reader, reader is this CSV file reader. So for every row in this file, we want to go ahead and print that row. We want to increment the counter, and then if the counter is greater than 10, we want to break. So we want to stop this loop. If we go ahead and run this now, so shift enter, control enter, or command enter, you will get this printed out. The first row, as we expect in a CSV file, is the names of all the columns. And then all the subsequent rows that are printed out are those data, those actual, from which each of those data rows themselves. So from this, you can see that we have the first column, or the first row as we expect, is the names of the columns, and then we have the data coming in after that. So if we actually want to go in and save this data into a usable format, because right now we're just printing the row, not actually doing anything. So let's just say we want to save the bit depth column as a variable and have it be a list of all the bit depths over time. What we can do then is, yes, there's a Q&A about asking whether or not reader.head10 is another way of doing it. Yes, it is. This right here is just a way that allows you to control exactly what you're doing with each of those rows. So what I'm going to do now is I'm going to copy this code. I'm going to paste it in this next little block because we want to import now these columns, and I'm going to continue playing with this code. So the first thing is we want to save this data as separate variables. To do that, we need a variable into which we want to save. So let's just say we want to have a time variable. So this right here is an empty array called time. And let's go ahead and do a whole depth and make that a empty array as well. So from this now, we want to go ahead and populate these variables with the data that's in our CSV file. So to do that, right now we're just printing each row. we need to do something a little bit more interesting than this in order to process it. So what we found when we printed each row is already in the format that it's an array. So it's already a list of numbers or a list of things. One thing that you'll notice in this list is each member of this list is a string. So you see how it's placed in quotation marks. So row is an array or a list of strings. It's not a list of numbers because it hasn't converted from the characters yet to the numbers. So in order to, let's say, capture the bit depth, or sorry, the whole depth. So the whole depth is this first column. So whole depth is the second column here. We need to take this number and convert it into a number before we can go ahead and play with it. So how do we do that? So for row and header. So we're now playing with that header. One thing that's always useful for when you're playing with data is to have a try catch or a try except. So you want to try to do something, and then if there's an error when you're running the code, you don't want the code to stop. Well, actually, before we do that, let's do this. So time append row at 0. So what we're doing right here is we're taking the element or the 0th element of the row, so the first element of this row column, or sorry, of this row, and we want to append it to time. So time is a list, we're appending that. Our whole depth, we want to do the same thing. And since we want a number, not the string of this, let's just go ahead and call float of row at 1. Because the whole depth we know is this is the second element. So in Python starts at 0, so it's row at 1. And we want to append it to our whole depth, and we want to convert it to a number. And we don't really care about the rest of these. Well, let's do the first 10 because I don't want to do the whole file right now. If I run this, we get an error. So there's a value error, and the value error says could not convert string to float, and the argument is whole depth in feet. Why did we get this error? The data starts in the second row, none of the first row. So that's why I was saying it's useful to have that try except. So let's just say try, and let's go ahead and do an except down here. And I'm going to go ahead, tab all those guys in, and tab that one out, except. So what's going to happen here is Python is going to try and execute this code, and if it fails, it's going to run whatever is in this except block. So let's just say print row error or row value conversion error, and I can't spell. So if we run this now, what we get is we get this printout of this row conversion error, and then nothing else happens. So what that means that all this code ran correctly, but we didn't actually print anything. So let's do one more thing. Let's go ahead and print time, and let's go ahead and print whole depth. So from this now, you've now gone ahead, your time contains all the time values, which are somewhat useful, and then you can contain all of your depth values. So the depth values are now numbers, the times are still strings. So again, useful things. So if you want to convert these times to actual useful time values, you have to do something with this row at 0 that you can probably look up fairly easily online. So that right there is working with a CSV file directly. That's a lot of code. We're lazy. Can we make this a little bit easier? So NumPy allows you to, or simplify this a little bit. So import NumPy, we're using this NumPy library again. And then within NumPy, there's a function that allows you to get data from a text file. So data is equal to NumPy dot gen from txt. What's the file name? So edr data.csv. And since it's a text file, we need to tell it what type of delimiter is. So it's commas. Delimiter is equal to a comma. And then encoding is none. So the encoding you need to put in there because certain files are encoded a specific way. If you tell it none, it uses the default for your area. So if you happen to be international right now and you're getting an encoding error, this part of this line needs to be changed because your local machine's encoding is different from the file encoding that I had on my machine. So that varies a little bit based on geography and an operating system. And let's go ahead, print our data. So if we run this now, delimiter, I need to figure out how to spell. There's an N in there, and run. Okay, so in here now, a single line of code has now converted the CSV file into a nice matrix. However, we still notice that this matrix has these nans in it. These nans correspond in the first row to the names of the columns, and then in the first column to these date times. So date time is a different type than a number. So NumPy doesn't really want to put two different types of data types into one of these NumPy arrays. So this is fairly useful if all of your data is numbers. If you have to do something else with the data, NumPy generally struggles a little bit. So how do you access data within it just quickly? So if you just type in data at 2,11 and print that, we get this 130.5.3. This number corresponds to this number right here. So we're accessing the second row and the 11th column. All right, cool. So, and then how do you access, let's say, a whole, an entire row, data at 2, colon mark, run that, and you get an array that is just that single row. So with this, with NumPy, you can access data fairly easily. However, again, it doesn't do everything we want. All right, so from this now, Pandas is the next greatest thing. Pandas effectively improves the operation of NumPy and gives you a lot more functionality. So import Pandas, data is equal to pandas.read CSV. So in this case, there's already a built-in CSV file reader, edr data.csv. Our separator in this case, again, is a comma, and our header row is 0. So the first row is our header row. This becomes useful if you're, let's say, playing with last files, where the header row is actually somewhere down the file, and you can go ahead and tell it which row to actually use. We run this, and after a few seconds, we can go ahead and see it. So that's already, so a last is a well log file. Last files are often occasionally used to move other types of data around as well because you have that useful header in it. But yes, thanks, Mark. All right, data.head, if we use that, we'll print the top of this file. So now what we see is we now have a very nice, clean format of our data with all the different columns. We have the time, and then we have row numbers. So Pandas now automates a lot of this file formatting, but the key thing is you still need to understand what your file looks like in order to use this. If you have, let's say, error numbers, you have negative infinities and things like that, Pandas will complain. So if you have those error numbers in one of these columns, Pandas will not be able to figure out that negative infinity or that negative error value is an error unless you specifically tell it. So that's why it's always useful to be able to look at the data before you use Pandas directly. The one last thing we need to do is time is still not a useful time object. So let's just say data at time. So we can access these different columns in data directly by calling the column name now. And let's just go ahead and convert it to a number. So to date, time, data at time. So what we're doing here is, oops, that's supposed to go there, and this is supposed to close. So we're going to repopulate our time column using this function, data.toDateTime of our original time column. We go ahead and run that. That's going to take a little bit of time because Pandas has to go through and convert every single value, so all 17,000 times. And then once that is done, we can do data.head again, and we can see that our times have now been changed into a datetime format. So previously they were in this string format. This string format you cannot use to plot. However, this datetime format now you can use to actually plot. So we now have our data loaded in. Let's go ahead and start plotting it. So for this, we use something called matplotlib. If you've ever played with MATLAB, matplotlib and MATLAB have very similar plotting functionality. So we're going to import the matplotlib.pyplot library, and we're going to call it PLT, because we don't want to call this every single time we want to do a plot function. So plt.plot, we want to plot some data. Let's plot time versus, let's say, depth. So data at bit depth. So we can access the data directly by the name of the column. If we look at the column name is this nice long thing with the units on it. So the easiest way, if you just copy that column name, place it in how you're calling it, now it's going to go and access this specific column. So it's going to go ahead and plot it, and now let's just give it some labels. So that X label, time, and plt.y label, and this is going to be bit depth. And this is in feet. That, and then finally plt, nope, I'm missing things, that one, plt.show. So we're plotting data. This is the X data, that's the Y data. Here are some labels, and now we want to show the plot. We run this, it thinks about things for a little while, and I clearly can't spell. Y label, rerun that, and we get a nice plot of time versus depth. So in this specific case, we have our 6 hours of time, and our depth goes from 2,600 feet to 3,200 feet. We can plot multiple things at the same time as well. So with this, I'm going to go ahead and copy this code because most of it can be the same. So we want to plot, let's say, bit depth, and then in the second plot, we want to plot, let's say, RPM. So in this specific case, we need to first define a figure. So a figure, and then just say our figure size is equal to 15, 10. 15 and 10 gives you the size of the figure in a certain unit, but the more useful thing is it gives you the aspect ratio of the figure. So it's going to be 15 units wide and 10 high. plt.subplot 211. We wanted this thing to be two subfigures high, one subfigure wide, and we want to plot in the first subfigure. We will go ahead and plot that depth. And now we want to plot something in the second subfigure. I'll just go ahead and copy this and paste. 2 tall, 1 wide, second figure now. And instead of plotting whole depth, let's plot, let's just say rotary RPM. D. And we're going to go ahead and paste that as the name of the column. And we can go ahead and name plot that as well. And we want to show the data. Let that do its thing for a little bit. And what we end up with is 2 plots that are, so 15 units wide. So you notice how it's a bit wider now, and it's only 10 high. And now we have bit depth in the top plot, and then RPM in that bottom plot, and then time is that bottom axis for both of these. So again, matplotlib, great tool to go ahead and start playing with plotting and visualizing this data. The last 2 things I want to do over the next about 5 minutes is quickly show you how to select data. So, and then use that selected data to go ahead and, let's say, apply a very simple regression to it. So, for this, what we need to do is select the data first. So let's see if we can quickly find my cheat sheet on this. So, to select that data, we can use conditionals. So let's just say we have, we want to find all the data we're drilling. How do we know if we're drilling, if we're just looking at drilling data? We are rotating, we have some form of weight on bits, and our ROP, sorry, the speed at which we're drilling is greater than 0. So we can use a couple of conditions to filter our data. So our drilling data can be our data that we've just imported, and we want the ROP to be greater than 0, and we want our RPM to be greater than 0 as well. So how do we do this? So our data at ROP, let's go copy and paste the name of that ROP column. So rate of penetration, take the name of that column, go ahead and paste that in. This, and now we want to say is greater than 0. So this line of code here will select all the data for which the data at ROP is greater than 0. And yes, this will be shared afterwards with all of you. So this will give you all the ROPs greater than 0. We also want all the RPM greater than 0 as well. So what we can do, put that in parentheses, and we can add in a second condition. So I'm just going to copy and paste that again. And instead of ROP, I want RPM. So let's go ahead, find what the RPM is called again. So rotary RPM, copy, and paste. There we go. So ROP greater than 0, RPM greater than 0 as well. And we run that. And that didn't like something there. It didn't like the RPM. That's because there's 2 parentheses there. We run that, and now our drilling data, so this variable just contains the data from data that is just drilling now. If we want to go ahead and plot this quickly, let's just look at, let's say, just bit depth. So I will copy this the data from this first plot, and I want to go ahead and, instead of using data, I want to use drilling data, copy, paste, and I want to plot this as blue dots. Run this now. The reason why I did blue dots is because I want to plot individual data points and show the gaps. So in this now, the drilling data has gaps in this data. These gaps are when you are not drilling. So this right here clearly makes sense. You are not drilling for a certain period of time, so we don't want that data. The reason why that's important, when you're, let's say, trying to use machine learning on drilling data, you don't want to try and learn the connections. Connections are not drilling. They're 2 different operations. So only use drilling data if you're trying to, let's say, make a machine learning algorithm that predicts ROP or things like that. All right. Final thing I want to talk about is some simple regression. So scikit-learn, sklearn, is a library that has a huge number of machine learning algorithms pre-programmed. We can go ahead and pull out the linear model, and let's just say we want to use linear regression. So to create linear regression, we need to have input data and output data that we're trying to predict. So input data, let's just call it X. Our inputs, let's just say we want to have our weight on bit data and our RPM data. So our drilling data, and we want to select 2 columns from it. We want weight on bit and we want RPM, so weight on bit. And that unit was K-pounds. And the second thing we want is rotary RPM. And that units for that one was RPM. So again, with your CSV file, these column names correspond to it. If you get sick of typing this, there are other ways of referencing columns as well, and you can make aliases. Just go and look in the pandas documentation for that. So that's our X's. We also want some Y's, and that is our drilling data, and that's supposed to be data. And we want rate of penetration. That is in foot per hour. Cool. So we have our X, we have our Y. In Python, it is very easy to create a model. You simply say model. This is our machine learning model, is our linear regression. So we're creating a new linear regression and we want to fit X, comma, Y. So we're getting the X is our inputs, Y is our outputs, and we're using linear regression, and we're trying to fit this data. Let's go ahead and look at the R squared for this, and that will be model.score, X comma Y, and let's just go ahead and print it. So our R squared is equal to our R squared. Run this, it thinks about life for a little bit. Hopefully it doesn't die. And of course, it complains about something. It is missing a rate of penetration because I can't spell. I'm just gonna go and copy and paste that. Rate of penetration. Paste, run that, there we go. So our R squared value for fitting rate of penetration using weight on bit and RPM is a phenomenal 0.26. So this model, if we just look at R squared, is horrible. But is it? Let's go ahead and take a quick look at the data, and that's where I will leave off today. Let's predict the data. So our prediction for Y is simply model.predict of X. And then our Y error is pretty much our Y predict minus our Y. So model.predict, it will go ahead and use the model predict based on the inputs, and that will store into our Y predict, and then error is simply the prediction minus the actual. And then in the interest of time, I will go ahead and quickly copy and paste my plotting code, because again, it's the same thing as we had previously. We had our data. I just need to make sure that it's called the same. Of course, it's not. My solution. So data. Oh yeah, right. This is also our drilling data. And if we run all this, we get our prediction. So in this specific case here, the blue is the, what did I call it? The blue was the prediction, the red was the actual. So if we're looking at ROP, so ROP on the y-axis versus time, we are now looking at what we're predicting. So red is the actual ROP. The blue is our predicted ROP based on these inputs that we used. The R squared value, if you remember, was 0.26. 0.26 sounds horrible. But if we look at the actual prediction, it's not bad. We're predicting right on for the first little while, and then down at the very end, we're starting to see a larger and larger error. So a simple way of thinking about it could be, this is now a different formation. Here, you're in the same formation. Also, the R squared value is large because of these artifacts that are occurring at this beginning and end of drilling. Because ROP is a derived value, while let's say a weight on bit is also somewhat derived. So these inputs are already derived, and it gives you these large oscillations at the beginning, and that gives you a poor R squared value. So from this, again, we've gone from data in a CSV all the way up to a simple prediction, and frankly, it's not horrible. So this hopefully gives you a good workflow of going from input data to visualizing and then starting to, let's say, play with it a little bit in Python. A key thing here, we did not separate our data into training, validation, and test data sets. So if you want to dive more into machine learning, definitely do read up on that, because this is just simply doing a regression on all the data. This is not how you would then start training your data in a true machine learning type context. All right. So with that, I will go ahead and conclude my aspect, and feel free to start asking questions. So there's a question right now asking about any advice on how to get into this. So for employers, the biggest thing that, at least that I've seen, is employers are looking for example problems that you have done, along with that certification of that you've done some form of courses. A quick plug for the University of Calgary, there is that software engineering master's program, and in it, you go through programming and machine learning in very large detail. And I know people who come out of that program have been in very high demand in these new data science roles. From just a current engineering role hopping into it, taking those courses and then getting that getting some practice with these tools is critical. And in my personal view, being able to, let's say, have example projects you can show during interviews is a great way of getting your foot in the door into those data scientist roles. So there is another question asking about whether or not machine learning can replace drillers. The problem with machine learning in any data-driven model is it can only act on things that it has seen before. So if it's seen it in a training data set, it can, to a certain degree, predict what the outcome will be. The challenge with drilling is there are a lot of new situations. So formations can constantly change. The tools you're using, so the drill strings, the rigs, the depths, the fluids, all of them are changing. So creating a comprehensive data set that covers all scenarios is extremely difficult. So in my view, machine learning will never replace a driller. A better way of thinking about it is machine learning can help augment the driller. So even as an example for this data here, if we're even just running this ROP predictor and we're seeing these differences, this predictor can give the driller information about the formation may have changed at this point, and it's an automated way, a more automated way of flagging that. So maybe that, let's say, that change should, let's say, cascade into a different change later on. And exactly, there's a comment right now in the chat about decision support algorithms. Absolutely. So the way I think about it is every model is wrong. However, every model can tell you something. And one key thing is your model is always built on some form of assumption. For machine learning, it is always because in machine learning, that assumption is you've seen that data before or that situation before. So if your model is starting to diverge from reality, it simply says your assumptions are breaking. And either your model is wrong or an assumption is wrong. If your assumption is wrong, that might be an indicator that something else is happening. Formation change. Maybe the drill is starting to break. Maybe you have vibration. In other scenarios, maybe your pipe is starting to leak, et cetera, et cetera. So it can start assisting with those types of, let's say, scenarios. Pandas can, so there's another question in the Q&A asking about LAS files. Pandas cannot directly read LAS files. However, there is a library out there that allows you to import LAS files. So just go ahead and search around it. I think it's a LAS library. When you're looking for it though, be careful because LAS is the same format that is used for LiDAR data. So that's the laser three-dimensional imaging data. So just make sure when you're looking at them, you're looking at well-logged LAS files, not LiDAR LAS files. And yeah, so there's one that's called LASIO. There's another one, I think that's called LAS Reader. What else do we have? There's one question on code about why there's two brackets for X. So in here, I had this X equals drilling data with double bracket here. So in Pandas, to select multiple columns, you give it a list of column names. So this right here is a list of column names, and then you're now going to access these columns from this drilling data. So X now is a table with two columns and all the rows. Y is a table that's one column and all the rows. All right. I think that's all the questions I see, and we're right at 1 o'clock. Perfect timing.
Awesome. Thank you very much, Roman. I think this was really helpful. I know for me personally, Python has always been a little bit intimidating, but after your talk, I definitely feel a little bit more confident that I could approach it, and I'm sure a bunch of our attendees on the line feel the same way. So thank you to everyone who's also attended. It sounds like we have people from near and far, so we'll get you back to your day. And just a reminder to check out upcoming events on the specalgary.com, as we have a couple events lined up for you guys in the next couple weeks. So thanks again, Roman.
All right. Oh, thank you for having me, and thanks everyone.